we're going to jump into the world of linear modeling. Now, in this first slide here, we're going to do a savings plan. So you'll notice in each of these examples, we start at 0, which generally when you start a savings plan, that's where you start. In 8 weeks, going up here, in 8 weeks, we're going to a baseball game. We'd like to have at least $100 to spend on snacks and souvenirs. That's legit. To ease the impact on the budget, we're going to set aside a little money each week between now and then, and in order to save for that. All right, so before we get into that, let's just jump down to number 1 here. How much money do you have to have set aside in the beginning, which is week 0? So when you decide to do this, you are at $0, right? That's pretty consistent across all 3 savings plans. Now, how much are we setting aside each week in the possibilities presented above and fill in the appropriate dollar amount? Okay, so to think about this, and it's a little bit hard for these graphs, but if you think about it, over 8 weeks, if you look, here's a point. This point is $0 at 0 weeks. Here, in 8 weeks, we have $40. So if I saved $40 in 8 weeks, well, 40 divided by 8, I saved $5 a week. Here, after 8 weeks, it appears we have $80. So $80 in 8 weeks gave me $10 a week. And here, I would say maybe 120. So 120 divided by 8 gives me $15 a week, right? So notice how I didn't go and look at any points here on the line in the middle. I used these points at the end. So when we're talking about linear modeling and we're looking at points, you want to find the actual concrete points where they have dots, because those are going to be a little bit more, I guess, accurate is the word I'm looking for. All right. And number 3, in which possibility would you actually have $100 at the end of the 8 weeks? Well, after 8 weeks, here we have 40, here we have 80, here we have 120. So we need possibility number 3, because here is where we'll actually have the $100 that we want to spend on souvenirs and such. So this kind of gets us into the concept of slope. Slope is often referred to as kind of a curly QM, and slope kind of describes the steepness of the line. So when you go back to those first 3 items, come on, here we go, you can see that this third one is a lot steeper, this one is flatter. And this one, these are actually our slopes in these. You can see 15 is a larger number than 5. So the larger your slope, the steeper your line. We also talk about this as the rate of change. So if you hear somebody talk about a rate of change, that's slope. If you're driving and you see the grade, 7% grade in the mountains or something, that is slope. Yeah, so slope is exciting. We do have a formula for slope. Slope is, in words, change in y over the change in x. And if you think about what does change mean, well, if you go to Walmart and you give them $20 and you want change, they figure out how much change you get by subtracting, right? So we're going to subtract our y values and subtract our x values. And we're going to get more into this exact example here in a little bit, but wait, let me see what next screen is. Okay, yeah, that's what I thought. In our last example, if we look, let's just look at this third one. We had points 0, 0, and this point was 100, there we go, 8, 120, because it was 8 weeks and then up 120. So we would consider this x1, y1, x2, y2. So if I'm subtracting my y's, I would take y2 minus y1 over x2 minus x1. Well, since x1 and y1 are both zeros, that gives us 120 over 8, and that's how we found the 15. So we essentially did this slope formula without even knowing it there on the first page. So let's go ahead and do some problems with this. The population of a city was 4,800 in 1900, but had dropped to just 450 by 2005. Find the slope. Well, the first part is that you have to have, ordered pairs in order to find the slope. And when we're thinking about, well, what's x and what's y, because it does matter, generally, the x is the independent variable. Usually, if you're graphing, it goes across the horizontal axis. And that is generally time. So because we have years, those would generally be the independent variable. So my first ordered pair would be 1900 4,800. And my second ordered pair would be 2005, 450. So again, I could say x1, y1, x2, y2. And no, it doesn't matter which one is x1, y1, which one is x2, y2. It'll come out the same when you do the math. So if I do y2 minus y1, just the y's always go on top. Because I started with 450, on the bottom I start with 2005 minus 1900. And I end up with the fraction negative 4350 over 105. Now, you could leave your fraction, your slope as a fraction, that's fine. Or you could turn it into a unit rate. If I divide that, I'm going to round, I get negative 41.4. And I'm going to talk about more of that when we get to, interpreting slope here in a few videos. So don't worry if you're not really sure what that means. But when you divide and get a number, that's like putting this over 1. So that's for every 1 year, the population goes down 41.4. That's what that means. Now, the negative slope basically means a decrease. If we have something that's negative, it's going down. If we have something positive, it's going up. Right? That's in general. Number 2. Dale takes a trip and finds that he was able to drive 350 miles in 7 hours. Use the slope formula to find Dale's rate of change. Now, right now you're thinking, well, to have the slope formula, I need 2 points, and they only give me one set of information. Well, true, but think about when you're getting ready for a road trip, your car will start either in your parking lot or in your garage or on the street. It starts somewhere. And that means before I go any miles, I went 0. In 0 hours, I went 0 miles, right? This is when I started my trip. Well, after his trip, remember, time comes first. So in 7 hours, he went 350 miles, right? That's the end of the trip. And again, remember, your x value is going to be any kind of time because time is generally on the horizontal axis as the independent variable. Now we can say x1, y1, x2, y2. So when I go to do the math, I could say y2 minus y1 over x2 minus x1, and I get 350 over 7, which is 50. And what does this mean? What does that slope mean? Well, my slope is 50. 50 over 1. That means I go 50 miles in 1 hour. So that is 50 mphs. That's what the slope represents. What assumption does that make? Well, it assumes that you are going at constant speed. Think about the last time you traveled. You might have averaged 50 miles an hour, but did you drive 50 miles an hour the whole time? No, you got to stop for red lights, somebody's cutting you off, you're on the freeway, so you're going 75, right? You're going all sorts of different speeds, but you average 50. Like my car keeps track of all of that fun stuff for me. My average speed in my car is like 47. That does not mean that I travel around everywhere going 47. No, that means when I'm on 80, 90 going to Chicago and I'm traveling 80 mile an hour, it balances out when I'm in town going 20, right? And everything in between. So it's the average speed. So the model assumes that you're going at constant speed, even though we all know that doesn't happen on a daily life.